All right, let's look at the homework 2.6, problem number 6, part A. All right, so I'm going to show you how to use GeoGebra to sketch the graph of the amplitude function. All right, so let's do that. All right, so C of omega, so GeoGebra uses X, so I'm going to just call this guy C of X, right, is equal to, right, F0 is 50, so I'm just going to type in 50, right, divided by, right, then we have a square root, so I'm going to say square root of, alright, so here you have, let's see, quantity squared, so I'm going to do, already put a square there. Right, K is, in this case, K is 45, so you have 45, and minus, M is 1, so I'm not going to write that, and then omega squared. So instead of omega, I'm going to use x squared, right? And then we're going to have to do plus, and then we have to square that. Right, C is the damping coefficient, which is 6. So we put 6 times, and let's see, omega again. So I'm going to just put the 6x, right? Then we have that, right? So we have this picture of the amplitude function. So I'm going to just move it around a little bit so that we can see it a little bit better. Right, so then maybe I might stretch it out so you can see a picture a little bit better. Right, so I'm going to maybe move it down right like that. Right, so you can see that so the amplitude in the beginning, so here's the omega value is omega axis here, and you can see that the amplitude gets larger and larger and larger, and somewhere around this point, which is about the 5 point something, and the answer is 3 square root of 3, so it's probably the right number. So it's at the 3 square root of 3 you're going to have the maximum amplitude there, right? But anyway, this is the way to sketch the graph of the amplitude function using GeoGebra. So basically you just have to type it in almost exactly as it is, right? That's it. I hope that this was clear.